Hey, Nathan here from PH Studios, and welcome back to another tutorial from the Tower Defense Engine series. Last tutorial we talked about the bullet class, and we coded that to the point where we can go on to another class. We have some methods that we will need to come back to, because it needs some functions in the tower, or monster, that we still need to write. So, Part 1 of the bullet class is complete, and now we're going on to the monster class. Now, before we get started, let's go ahead and copy all these using statements up at the top, except for the particle system library. Go ahead and copy those. Let's go to the enemy folder, and let's open monster.cs, and let's paste those using statements. And then we should be ready to go. Alright, now monster is going to be a derivative of gameplay object. We want some functionality that's found in the gameplay object that we have created in the past. Alright, so there we go, and let's go ahead and copy this namespace, and let's go to the gameplay object, and let's go to the very top, and let's paste that namespace in there. So now it is aware of gameplay object. Alright, so for this monster class, we need a few things like health and the texture, of course, and what we want to do when we hit the monster. It needs to change to a hit texture, and then it needs access to the maximum amount of health it can have, and when the monster is hit, we need to throw a sound from the audio engine. So it needs access to the sound name that we want to use. Just a few more things like that, and then we will need to add a few more things. So let's go ahead and do that right now. Just like the bullet class, we need to have a region for the monster reader. And then we need to have an end region. And then we can start working on our attributes and properties here. So this one is going to be content serializer, and it's going to be public int health. And we're going to get and private set. And then we need to have a max health, and that's going to be ignored. Public int max health, get and private set. And now we need to have a texture asset. It is a string. And then we're going to do get and private set as well. Alright, and now when we hit the monster, we want it to change to a hit texture. So go ahead and copy the texture asset code that I have highlighted here, and paste it below, and just add the word hit in front of texture asset, and that will be all we need to do. And now for the actual textures, it's going to be a texture 2D, so it's going to be ignored. Public texture 2D, and then it is texture, and then we will have hit texture. Content serializer ignore, public texture 2D, and then it's hit texture, get and private set. Alright, so now we need access to the sound effect that we want to play whenever the monster is hit. Now that is referred to a cue. So what I'm going to call this is a We will serialize it. It will be in the XML, and I'm going to call it a hit queue name. It's going to be a string hit queue name. And that way we can call just the audio engine and pass it this string value, and it will play the sound. Alright, now is boss. We need to have a way to determine if the monster is a boss. If the monster is a boss and it reaches the end, we will get twice the lives taken away. If we kill the monster and it is a boss, we will get double the money. So we need a way to determine if it is a boss. Now, this is not a requirement. So what we need to do is we need to have it as an optional attribute that we can put in the XML. So I'm going to do content serializer, and whenever we want to create an optional value, we do opening parentheses, optional is equal to true, closing parentheses and closing bracket there, and then public bool is boss. Get and private set. Alright, so now the monster needs to be aware of what wave it is part of. Now this does not need to be in the XML, so we will ignore this, and we'll just say public wave get and private set. Actually, let's take out the private right there. Alright, now a monster is determined to follow a set path. How it knows where it is in the path is handled by a path index. Every monster has its own path index, and it represents which section of the path it's on. And that will be an int value, and we will ignore it. So it'll be public int path index get and protected set. Any derivatives, if we ever create monsters, we want to have this as a protected set, so derivatives can modify it. Alright, now to make things a little bit more interesting and to cover the basis and make it more foolproof, we need to determine whenever we set up a new path index, we reach the end of we go from one node in the path to the next node. Then we need to do some math and determine how far we need to travel to get to that next node. So we will be handling that by two float values. We need to determine how much we need to travel and how much we traveled already. If how much we traveled already is greater than the how much we need to travel, we need to increment the path index. So these are both ignored. And if you watch my XNA tutorial on content serialization, I created the little pathing sample where just a box would just follow a dedicated path. And in the code, I do the same thing in this as I did in that video, and code in where we need to calculate the distance to travel and how much we've traveled already. So we have get and private set. So if you want to take a look at that tutorial, that's what I did there. We will ignore this, and this will be the distance we traveled already. Public float distance traveled. Get and private set. Alright, so whenever we start a wave, we say wave starts in 5, 4, 3, 2, 1. The wave has begun. And then we start throwing monsters out of the spawner. Now, sometimes one monster would appear, and then 10 seconds later, the next monster would appear. They're still in the same wave, but another wave might have one monster appear, and then half a second later, the other monster will appear. So we can determine how fast we want monsters to spawn, how close we want them to be together, or how far we want them to be apart, and that is based on the monster's delay timer. So we need to have a float property here. It will be ignored, and let's call it delay. And delay is both get and set. Okay, so for our bullets and our towers, we need to be aware of the monster's state. Is it an active monster? If it is, we can fire at it. If it is active, we can target it. The tower will target it. So if it is active, which means it's not in a delay state and the object status is active, the whole monster is active. So this will be ignored, and we will just have a get. And in the get, we need to have more logic added to it than just a get semicolon. So it's a public bool is active. So we'll just have get, and we'll have opening curly brackets, just like that one there. Return delay is less than or equal to 0, and status. How did I get status? We got it from the gameplay object class right there. When we created this as a derivative, we gained access to status. So if status is equal to active, and it's not in a delay state, then we just return that logic there. Alright, so now for some variables and fields. We need to be aware of the timer so we can know when to actually start our pathing process. If it's in a delay state, we need to have a timer. Hi, I'm back, and I had to split the tutorial into two. So we left off when I was talking about the timer, right? So let's go ahead and add the timers. Now these will be fields only, so they do not need to have public access or anything like that. So we have a float and hit timer, and that's going to be determined when we hit the monster. It's going to have a timer to display the amount of damage that we dealt. If you play the game, you will notice that we have a damage in a string value that whenever we hit the monster, it'll display that number next to the monster. That's what the hit timer is responsible for. Now we have a float for statistics timer. Alright, so now we use the UI element for text, and that is hit display. Alright, now we have a float delta health float. This is for the actual special abilities. Remember, I hard-coded the damage over time and area of effect for right now, so we'll need to hard-code them into the monster class itself. So we have a float for the dot timer, float for dot time, and int dot health. Alright, so those are pretty self-explanatory. The delta health, we will increment that, and then when it's above 1, we will decrease our overall health. Because we have dot time and dot health, let's say we have 1 health over 10 seconds. It's going to take 10 seconds for the delta health to become 1, and then we apply the change to our health, because our health is an integer, not a float. So that's why we have to do it that way. Alright, so now we are going to have the monster be more event-driven than our past tutorials, where we just check to see if our monster is dead or if our monster is hit or something like that. for this game, we are going to do the event-driven approach. So we need to have public event handler, die event. When an enemy dies, we want to throw an event to all the listeners and everybody that wants to be aware of when a monster dies. We can perform logic based on that. Public event handler, and hit event. Again, when a monster's hit, certain classes and objects will want to perform logic. Alright, so that's it for the properties and attributes. So now let's worry about the methods and constructor. Now, just like the bullet class, we're not going to do much of any coding in the actual method. We're just going to get things ready, set up the return type, the access, the method name, the parameters, and all that stuff. Alright, so let's go ahead and get started with the constructor, public monster. Alright, public override. We're going to override the update method. Alright. Private void. This is where we will do the special effects. So, private void update damage over time. We'll pass a game time with game time as a name. Alright. Internal void apply dot. So whenever the bullet hits the monster, it'll apply dot if it's a damage over time bullet. So an int damage and float time. Damage over time needs damage and then time. Now we need a public void new node in path tile t. Again, I mentioned this at the very beginning of the tutorial that we'll have a path index. Now we get the new node in path whenever the path index gets incremented. Public void add to wave w. Now, since wave is a public, we probably could get away by setting that up to be private. But I like to have an add to wave method to add it to the wave. Public void hit bullet tower owner. What bullet hit me and who is the owner? That's what that does. It just performs logic. It decreases the health of the monster. And that's just what's called whenever the bullet hits the monster. Alright, so obviously if we have any game elements, we obviously want to draw it. And we probably want to draw it differently than the main gameplay object class draws. So let's override the draw method. And one last thing. We need to have this as a clonable object. Alright, so let's go ahead and fill in the clone because that is that's a pretty basic thing to do. So let's just go ahead and set monster, name it whatever you want is equal to new monster, and then just set all the basic attributes it needs and properties. Like it needs the same name, it needs the same description, alpha, speed, health, max health, texture asset, texture, hit texture asset, hit QName, hit texture, is boss, and path index. And the path index is set to -1. So let me read that off again for those of you that need to know which ones you need to duplicate in the clone. You need to copy the name, description, alpha, speed, health, max health, texture asset, texture, hit texture asset, hit QName, hit texture, isBoss, and set the results, whatever you named it, the results, path index as -1. This line I highlighted right there, that is very important, that it should be -1. And at the end of all this, you want to return the result. So that is the clone method. Alright, so the last thing we need to do is we need to set up the writer. And let's actually code that above the clone method. Region writer and region. Alright, so let's go ahead and code the writer first and then the reader. So this is going to be a public class monster writer. Let me just double check that. So we have reader at the top and writer at the bottom. Alright, so monster writer, content type writer of type monster, and then we hover over the C, and then we get the implement abstract class. Alright, so as I mentioned in the past, every time you get this method to get runtime reader, you can just do return type of, and then the actual writer. We haven't made it yet, so it's going to complain about that line. But then we can go ahead and code the write method. Okay, so in the write method, just like always, anytime you have a content writer and a reader, you want to write and read the same way you set up the class. So of course we want to do health first, then max health is obviously ignored, so we do not do that. So we do health, then texture asset, and all the way down the list. So let's go to the write method and let's set up output.write. Now, since this is a derivative of gameplay object, it's going to be a little bit different to do this. We need to write the gameplay object data first. So we need to write raw object. It is a gameplay object. And now we have a value here, the monster value. So now we need to do opening parentheses, value as gameplay object. Alright. Now we close that and then semicolon. And then we do the rest of the stuff. So our health, texture asset, and all the way down the line. Output.write, value.health, output.write, value.texture asset, output.write, value.hit texture asset, output.write, value.hit QName, output.write, value.isBoss. So those are the only things we will add to the XML files. The health texture asset, hit texture asset, hit QName and isBoss, and of course our gameplay object data as well. Alright, now since we're dealing with the derivative, we need to add one more thing to the monster writer that we have not done before. Gameplay, at the very top, let's add a field. Basically, this is another class of monster writer. So let's add a field called gameplay object writer and name the whatever you want it to be called, and then set it to null. Alright, so we need to override the initialize method. Delete, you want to keep the base. And then the gameplay object writer, whatever you named the field up there, is equal to compiler dot get type writer type of gameplay object as gameplay object writer. Semicolon. Alright, so we need to gain access to the gameplay object writer, and then in the write raw object, we need to do one more thing, and we need to pass that so it knows what to use. Gameplay object writer. So derivatives are a little bit messy when you're dealing with the content writer and readers. Alright, last thing we need to do is populate the read method. And that's a little bit easier to do. So let's go ahead and do that. Public class monster reader is a derivative of content type reader of type monster. And then let's implement the abstract class. Alright, delete the throw new non-implemented exception. Monster result is equal to new monster. Whatever you want to call it. Input dot read raw object. Remember, we want to read the same way we wrote the information. So we wrote the raw object gameplay object. So we need to read the raw object gameplay object. Gameplay object result as gameplay object. We need to do the we need to cast result as a gameplay object, and we use as to make sure it becomes null if we don't have it as a actual gameplay object. So we set result as gameplay object and pass it to the reader in gameplay object. The reader is down here where we read the data. And then if it is null, then we set it up as a new gameplay object. Then we return it down there. Alright, so once that's done, we got the gameplay object going. So now let's do the rest of it. Result.health is equal to input.readInt32. Result.maxHealth is equal to result.health. Result.textureAsset input.readString result.texture is equal to input.contentmanager.load. It is a texture 2D, and we need to pass it the actual path to the monster, which is going to be string.format textures / monsters / opening curly bracket 0 closing curly brackets end quote comma result dot texture asset. closing parentheses, and semicolon. Alright, result dot hit texture asset is equal to input dot read string. Result dot hit texture is equal to input dot content manager dot load. It's a texture 2D, and we need to pass it string dot format. And the path to all of our textures, again, textures, monsters, opening curly brackets, 0, closing curly brackets, and the result dot hit texture asset. Result dot hit queue name is equal to input read string. Result.isBoss is equal to input.read boolean. That will read the boolean information we have in the XML. And then result.pathIndex is equal to 0. And then we return result. Alright, so that's it for the readers and writers. And that's it for the monster class. For now, this is part 1. Part 2, we will actually fill in these methods. But for part 1, this is pretty much it. So, I hope you enjoyed this tutorial. It was actually 2 tutorials in 1. So it's a pretty long tutorial. Lots of stuff to cover. So I hope you enjoyed it. And I'll see you next time for the tower class. Thanks, and see you next time.